inequalities and how they work. Okay, inequalities are going to have to be graphed on a number line. And just so we remember how the signs go, strictly less than, strictly greater than, those get parentheses. Greater than or equal to, less than or equal to, those get square brackets. Negative or positive infinity, they get parentheses. Okay, so that's just kind of a quick review before we begin. So far we've got 3 and 7 on the list. We can add more if we need to. What else do we need to remember about inequalities? Well, when we divide or multiply by a negative, normally it's divide, what happens to our inequality symbol? That gets flipped around as well. Okay, so those are just things to remember. So when we go to graph them, strictly greater than, strictly less than, those get parentheses. Greater than or equal to, less than or equal to, those get brackets. Positive or negative infinity, those get parentheses. Okay, so we're going to begin with question number 3. And this is a double inequality or a 3-part inequality. And we need to go ahead and begin by clearing out our fractions on this one. Okay, so this is question 3 from your homework. We're going to have to graph this. Now, first thing we need to do is we need to get rid of our fractions. And so the only fraction we have is the one in the middle. So we're going to multiply everything by a negative 2. And when I multiply everything by a negative 2, what's going to happen now to my inequality symbols? Well, they're going to flip around, aren't they? So let's see what we've got. Negative 2 times negative 1, that is a positive 2. Flip your inequality symbol. Now here, those 2's, they directly cancel. So those are gone. So in the middle, we're left with an x plus 1. Flip your inequality symbol. And negative 2 times 3, that makes it a negative 6. Now we should know what to do. So we're going to move that negative 1 over. And now we're left with this. When we go to graph it, we need to make sure that we put it in the correct order. So right now, when we flipped our inequality symbols, okay, that also changed the order on the number line. So since we flipped our inequality symbols, that also changes the order on the number line. Because remember, the negative numbers are on the left, so negative 7's there. Larger positive numbers are on the right, so that 1 is there. These are both now going to get square brackets. And my answer is right here in the middle. And what would that look like in what's called interval notation? Well, in interval notation, it would be negative 7 to 1 with the square bracket. So that one's a pretty easy one. We do not have to check anything on these. We only have to check the nonlinear ones. So that was question 3. And the last question that we ask about is 7. We can add more.
Yeah, I would ask the
Number 4? Sure. Yep, we can add 4 to the list. Did we have any others to add? Okay, so we've got 3, 4, and 7. We'll go ahead now and work on question 4 next. Now 4 is nonlinear. So 4, we're going to have to put it on a number line, solve it, and get our solutions. So 5 plus 4x, quantity squared, is greater than or equal to a negative 4. Now on this one, I can already tell you that my solution is going to be all real numbers. Now how do I know that? Without even doing any work at all, we're going to do the work to verify it. But let's think a little bit about how numbers work. This is a quantity squared, right? Now, what happens if I square a negative number? What does it become? It becomes positive, right? If I square a positive, it stays positive. All positive numbers are always greater than what? -4. So it's true all the time. Now, we're going to verify this by solving it, but my answer should be all real numbers because this is squared, meaning it's always positive or 0, and it's always going to be bigger than -4. So it's true all the time. We can verify it. We're going to solve this first, so we don't lose it. We'll keep track of that. We're going to go ahead and make that an equal sign. Okay. And we'll take our square root. Now, remember, what happens whenever we take the square root of a negative number? It comes out as a imaginary, doesn't it? Now, we don't have to do any more from here because what do we know? This is imaginary, and imaginary numbers can't be plotted on the number line. What this says is when you get an imaginary number, it means it's either always true or it's always false. One or the other. Never changes. When we solve these and we get numbers, they're where they switch back and forth between true and false on the number line. Since this is imaginary, that means it is always true or always false. It never changes. And I think the one that we went over last time, when we looked at examples, I think it came out to be false, no solution. This one's going to be the opposite. So let's pick a number to check. Doesn't matter what number we check, because it never changes. So I'm going to check x equals 1. And I'm going to plug that back into my original. And we're going to see what happens. Well, 4 times 1 is 4, plus 5 makes it a 9. And 9 squared is going to be what? 81. And is 81 greater than or equal to a -4? Yes, it is. It's bigger than that. So that would make that true. It's true everywhere. So if we drew it on a number line, what would that look like? That would just look like your entire number line shaded. And your answer would then be negative to positive infinity. Now, if it would have been false, what would my answer be? No solution, right? Okay. Why do we check it this way? Because we get imaginary numbers. And those tell us that it never switches between true and false. It's either always true or it's always false. And so we pick a number, any number. I usually pick 1 because it's easy to work with. We check it and we see if it makes it true or if it makes it false. If it's true, it's everything. If it's false, it has no solution. Someone also asked about question 7. And it's similar, but it is a little bit different here. Because it actually has solutions, and we're going to have to check them. Now, I can already tell you that this one is going to have no solution. And let's talk about how I know, without even solving it, that this one has no solution. Well, again, think about what happens when you square a number. When you square a number, it becomes either 0 if it's 0 or it becomes positive. So this side is always positive. And are positive numbers smaller than 0? No. So that would make it false. But let's check it on a number line. Let's get our solutions and let's check it. So this is our original that we're going to be using to check. And if I go to solve this, this is actually two separate equations because it's two parts. So the first one is x squared equals 0. Right? And if x squared equals 0, what would we do to solve this? Well, we've got an x squared, so we take our square root, and 0 is unsigned, so we don't have to worry about the plus or minus. And so one critical point is going to be x equals 0. What about the other one? Okay, what's our other one? So here's a piece, here's another piece. Our other one is x plus 16. Quantity squared equals 0, right? Okay, and how do we solve this one? Same way, square root property. Square root of 0 is 0. You could put the plus or minus, but 0 doesn't even have a sign. So that gives you x plus 16 equals 0. So my other one is negative 16, right? So those are the two numbers I'm going to check. These are called critical points. These are the numbers that are going to go on the number line and make the regions. Now, it should come out to be false everywhere. We're going to check each region and we're going to make sure. The reason why I say it's going to be false everywhere is when we start squaring numbers. Okay, when we square numbers, they become either positive or they stay 0 if they're 0. And those are always going to be bigger than 0, and this says they're smaller. So it should come out to be false every time. Let's put these on our number line, and let's see what we're dealing with. Minus 16 and 0, and so we'll make our regions. Number smaller than minus 16, how about minus 17? Number in between here, how about negative 1? Doesn't matter what we use. Bigger than 0, how about we use 1? Okay, so those are going to be our critical points. The numbers we're going to check are going to be minus 17 because it is less than the negative 16. We need a number in the middle, and negative 1 is in there. Use the easiest numbers possible. And we need a number bigger than 0, and so we use a 1. So let's go ahead and plug our values in. And we're going to have to use x squared times x plus 16 squared is less than 0. We're going to have to use this to check. So let's start with a negative 17. Okay, and you can check signs. We'll just go ahead and work it out completely. You can also get by just by checking signs, but let's go ahead and just work it out and see the number. So 17 squared is a 289. And negative 17 plus 16, it makes it a negative 1. And what happens when you square negative 1? It becomes positive. So this side becomes a 289. And is 289, is that smaller than 0? Is that going to be true or false? Is 289 smaller than 0? Someone said it. That will be false. So that region is false. Okay. What about the next one? The next one we're going to use is negative 1. So if I plug in negative 1, I have negative 1 squared times negative 1 plus 16 squared. And let's see what happens here. Negative 1 squared is 1, right? Negative 1 plus 16, that's 15 squared. And 15 squared, okay, that comes out to be a 225. And what do we know about 1 times 225? It stays at 225. And is 225 smaller than 0? True or false? That, again, would be false. And our last one. Okay, last one we're going to check is we're going to check 1. So check it, and it should also be false, because this should be no solution, because we square negatives and they become positives. So if we plug in the 1, we have 1 squared times 1 plus 16 squared. And so that's 1 times 17 squared. And 17 squared is a 289. And 289 is not smaller than 0. So that makes that false. Now, what do we notice on our number line? All the regions are false, right? When we go to write up our answer, where's our answer at? Our answer is going to be in the true regions. Well, do we have any part of this at all that is true? No. So none of it is true. So your final finished answer would be no solution. And I may put something like this on your exam, where you could look at it and tell ahead of time if it's going to be true or false, or you could work it out. So I might put something like this on there, where it's easy if you watch your signs, or you can spend the time to work it out. But this is something that you might see as one of your exam type of questions. This one, probably also something like question 3 and question 4. Okay, question 3 just because you got to switch the signs, and question 4 because it's the opposite of this one. Okay, so that has no solution. Did we have any others out of 1.7 to look at? Does anyone need the homework packet from last time? Does everyone have the homework packet? I think everyone does. I think everyone was here last time. Okay, so let's now go ahead and talk about absolute values next. And that's going to be 1.8. Anybody else have any questions? No. Okay. Well, we're going to move on to 1.8, and it's going to be an easier section. So we're going to look at 1.8 here, and we're going to talk about absolute values. Okay. So absolute values, these are going to have multiple solutions. When we look at absolute values, we get 2 solutions normally, and sometimes it may have none. It depends upon what it is and how it works. But normally absolute values give you 2 answers. Here's an example of one that we can just look at and see why we get the 2 solutions. Let's look at the absolute value of x equals 7. Well, there's actually 2 numbers that'll work. What would the 2 numbers be? What number can I take the absolute value of and make it 7? That's pretty easy. That's going to be what? 7. Okay. And what's another number that also gives you an absolute value of 7? Negative 7. And why would that one work? Because when you take the absolute value of a negative number, what comes out? Positive, right? And the absolute value of 7 is 7. The absolute value of negative 7 is also what? Positive 7. So when we work out these absolute values, we're going to have to get 2 equations, and we're going to have to solve them separately from each other. And we'll also look at some that have no solutions later on. But right now, we're going to focus on the ones that have solutions that we can solve. And then once we've solved them and understand the equations, then we'll look at inequalities. Okay, so let's go ahead and solve some of these out. And hopefully this should be review for most of you. Okay, most of you have probably seen absolute values before, and we should know how to solve them. And we'll start off with an easy one. So this is what I want you to solve. Now, absolute values, you are going to get 2 equations to solve. A lot of times what happens is students will get the first equation but not the second equation. Or they will make a mistake and change the signs in the absolute value. So let's go ahead and take this and get our two equations. So we know this is what we're going to have to solve right here. Get the two equations. What would your two equations look like? Well, for the first one, what we do is we simply drop the absolute value bars. So we're going to drop the absolute value bars, and that would be 3x minus 9 equals 8. The other equation, and we use an or to separate them, the other equation would be 3x minus 9 equals a negative 8. Now, did I change the sign of that 9 in the absolute value? No. Notice it was negative and it stayed negative, didn't it? What did I change? The only component I changed was I changed this 8. So one of them is a positive 8. The other one is a negative 8. Now we have our two equations. We can solve this and we can get our two solutions. So we'll go ahead and solve this quickly. Solve each one independently. So we'll add our 9. So 3x now equals, looks like 17. Divide by the 3. And so x equals 17 over 3. There's one solution. Bless you. What about the other one? The other one, we're going to add our 9 over. And so 3x equals now, adding those together, 1, right? Divide by our 3. And so our second solution is x equals what? X equals 1/3. So does everyone see how we got two solutions? So what's the important takeaways here? Okay, the important takeaways are I get two equations, and did I change the sign of this negative in the absolute value? No. Those are the two things that I see students make mistakes with. They'll only give me one solution, or they will change the signs inside of the absolute value. And the signs inside, they never ever change. Let's do another one. Okay, now this one, I also see students make a mistake on. Okay, I've taught absolute values for 20 years, and this is where students will make a mistake. That negative 8, okay, what needs to happen with that? Before we can work with this absolute value, that absolute value has to be by itself on the left-hand side before you do any other work with it. So before you get your two equations, you have to get the absolute value by itself. So this needs to be by itself on the left. So the absolute values must be by themselves on the left. So what I'm going to do is I'm going to add my 8. Before I do anything else, you have to make sure that absolute value is by itself on the left. So I'm going to move that 8 over. And minus 2 plus 8, that makes it a 6. Now we can get our two equations. But where students make a mistake, and I see it happen all the time, is they will try to get this 8 and put it inside the absolute value. And it is not. It is separate. So that 8 is separate. So I had to move it over to get the absolute value by itself. It has to be by itself on the left. And now what do my two equations look like? Well, they are minus 5x plus 2 equals 6, or minus 5x plus 2 equals now a negative 6. So we get a positive case, and we get a negative one. Did I change the sign of that 5x in the absolute value? No. Right? This stayed negative. A lot of times I see students make mistakes because they think absolute value make everything positive, and that does not work. Separate it out, get the two equations, and now you simply solve each one. So move the 2 over. So minus 5x now equals 4. Divide by your negative 5. And now we have x equals negative 4/5. So there's one solution. And what's my other one? Well, my other one, do the same procedure. Move the 2 over. So minus 5x equals now a negative 8. We'll divide by a negative 5. And negative over negative now makes that a positive 8/5. Is everyone okay with how I did that? So make sure that the first thing that you do is you get that absolute value by itself. So that 8 has to be moved over. Let's do another one of these. And we'll look at 0 this time. So let's try and solve this one. Okay, so let's say I give you this one to solve. Okay, what's the first thing I need to do? Before anything else is done, that 9 has to go away, be moved over. So I'm going to add that 9 to each side. So that's our step-by-step procedures. Get that absolute value by itself, okay, before we build our two equations. So now we've got the absolute value of 4x plus 2 equals 0. This one is only going to have one solution because 0 is unsigned. So we don't have a positive and a negative case. We only have one. And so what's this going to give you? 4x plus 2 equals 0. Okay, so 4x equals a negative 2. Divide by your 4. And our only solution is negative 1/2. Because 0 has no sign. And so we only need one equation. Is everyone okay with that so far? You can also have an absolute value equaling another absolute value. So we'll do a couple of these. You're going to use the same procedure and the same logic, though. Okay, and these are absolute value bars here. Make sure we see them there. Absolute value bars. Okay, so what do we have? An absolute value. Now, when we work with an absolute value, you should end up with two equations. So the first one, we drop the absolute value bars. So the first one is very simple. We drop the bars, and that is 4x plus 5 equals 3x minus 2. What's the other one? Okay, well, the other one, what we do is we keep the left-hand side the same. So 4x plus 5 equals. We take the right-hand side and we put a negative in front because that is going to force us to change the signs. So one of them, we just drop the bars, easy enough. The other one, we have to distribute a negative through on the right-hand side. So let's go ahead and work this out quickly here. Shouldn't be any problem to do. Move that 3x over. Move that 5 over. Okay, and 4 minus 3, that leaves you with a single x. And minus 2 minus 5 makes it a minus 7. So there's one of them. Okay, so that's a negative 7. That's our first solution. What about the other one? It's 4x plus 5. Distribute that negative through. So that makes it a minus 3x and a plus 2, right? And move things around again. So add the 3x, move the 5, and now we've got 7x equals 2 minus 5. That's a minus 3. Divide by our 7. And our last one is x equals now negative 3/7. Make sure I didn't make a mistake anywhere. I don't think that I did. Everything looks right there because distributing that negative through makes it positive. Okay, I move that 5 over with subtraction. I gave you that negative 3. I move the 3 over with the 4, makes it a 7. Divided, and I got my 2 solutions. So these are our 2 solutions here. One more of these, and then we will look at inequalities. So one more of these, and then we'll look at our absolute value inequalities, which those are the ones that students struggle with more than equalities. So let's solve another one. Okay, so absolute value equaling another absolute value, right? Okay, so first thing we do, these are absolute values here. Okay, so the first thing that we're going to do is we're going to come up with our 2 equations. The first one is the absolute value of 4x plus 15. So that gives you 4x plus 15, stays the same, and it equals a negative 2x, right? Okay, so there's our first one. We just simply drop the absolute value bars. What about the other one? The other one is going to be 4x plus 15 equals a negative 2x, right? And we know the negative here, negative and negative makes that a positive. So that side's going to come out to be a positive 2x. The other one's a negative 2x. So now we finish it. Just move things around however we want to. I'm just going to move that 4x over. And minus 6x now equals 15. Divide by our negative 6 and reduce. Reduce this down here. And what's that going to reduce down to? Well, it looks like, okay, 15 and 6 have a 3 in common. So it looks like it's going to reduce down to a minus 5 over 2, isn't it? Is everyone okay with how I got that equation? Right? All I did was I dropped the bars. That gives you one of them. How do you get the other one? Switch the signs. So drop my bars, and I just moved that minus 4x over. And that gave you a minus 6. And I put it on the left because I like to have the x on the left. So I did that. 15, nothing to go with that. Divided by my negative 6. 15 and 6 both have a 3 in common. So that left you with the 5. And 6 divided by 3 is a 2. One negative keeps it negative. What about the other one? It stays the same. Double negative makes it a positive 2x. So we have 4x plus 15 on the left. Double negative makes that a positive 2x there. So move your 4x over with subtraction. And I like to rewrite it on the left. So now we have a minus 2x, and that equals positive 15. Okay. Oh, yep, everything's right there. Make sure I don't make any mistakes. Everything looks correct. Just double checking things. Now what do? Divide by our negative 2. And what's my final answer? Minus 15 over 2. Is everyone okay with these? And again, the first section and the last section of every chapter is always the easiest. These are very simple to do as long as you remember to get the two equations at the beginning. You get the two equations and you solve them independently. Now let's look at our absolute values, inequalities. So absolute value inequalities, we're going to have to check these. So we're going to now be looking at absolute value inequalities. This is going to be solved and worked out the exact same way that we would work with an equality. Only the difference is now we have to put them back on the number line. So these have to go back on the number line. So let's put these now, solve it, get our two equations and put them on the number line. So let's look at our two equations. What would our two equations be? If I split this up, this is my original. And after we work through these absolute values, then I'll go back and finish up 1/7. I just forgot to do that. So we'll finish up 1/7 after we do 1/8. Okay, so this is our absolute value inequality. So what would we look at when we solve? We're going to solve these two. Okay, 5x plus 3 equals 9, or 5x plus 3 equals a negative 9. So there's our two equations. Now, the difference is when we solve these and work them out, these are going to have to go on a number line. And when they go on a number line, you only have two choices. We'll talk about both of them in a moment, but it's either in the middle or the ends. So let's solve these out. We have to do that. Get our two solutions, two critical points. 9 minus 3 is a 6, so that gives you x is 6/5. So there's 1. Move the 3 over. So 5x equals negative 12. So x equals negative 12/5. There's the other. We are not done yet, though. We are not done because they have to go on the number line. And make sure they go in the correct order on the number line. Very, very important that they go in the correct order. So there they are. And that makes our regions. Now, we only have to check 0. So the only one you have to check is 0. That's it. On these, just check 0. We don't have to check any others. All we have to check is 0. Now, where is 0 at? All right, in this case, 0's in between the two numbers, so here it is. So we plug it back in our original, and we check 0. That's it. No other number, just 0. Because one number is going to give us the solution that we need. And the easiest one to always pick is 0. So let's check 0. So if I check 0, okay, 5 times 0 is 0, plus 3 makes it 3. The absolute value of 3 is 3. And is 3 going to be larger than 9? Is that true or is that false? Is 3 bigger than 9? False. That means it's false here. Now, when we go to get our answer, the signs always switch back and forth. So your answers are either true, false, true, or they are false, true, false. Now, which one is false? In the middle. So the middle is false, so the outer edges must then be true. Okay, it's always either true, false, true, or false, true, false. They switch back and forth. Now, where is it true at? It's true on the edges. And am I going to use square brackets or parentheses? It looks like I'm going to use what? Square brackets. Okay, and this is negative infinity here. This is positive infinity. And so what does my answer look like in interval notation? Well, it looks like negative infinity, comma, negative 12 fifths with the square bracket. We use a U for union, 6 fifths, and it goes to positive infinity. So this would be your final finished answer. Let's do another one. So we're going to solve this out just like we've done the others. Okay. And what do we need to do first? Before we do anything else, just like when we had an absolute value with an equal sign, we need to make sure that that absolute value is by itself on the left. So before we apply any other rules, what do we do first? We have to add what? We have to add that 4, don't we? Right? So make sure when you work with these that the absolute value is by itself on the left. So add your 4 to move that over. Now you have the absolute value of minus 8x plus 1 is less than, when we add them together, positive 6. I'm going to box it so I don't lose it, because this is my inequality that we're going to work with. So we've got it. I moved it over. This is what we're going to check it in. Now, we need to solve it. So what are my two equations? Minus 8x plus 1 equals 6, or minus 8x plus 1 equals a negative 6, right? Okay, so let's go ahead and finish this out. So solve each one. So move the 1 over. So minus 8x now equals 5. Divide by your negative 8. And x now equals a negative 5/8. So there's 1. What about the other one? Do the same procedure. Move the 1 over. Okay, so we've got that. Divide by your negative 8. And that gives you x now equals 7/8. There's the other one. This is an inequality, so we are not done yet. We need to finish it. So what do? It's an inequality, so they go on the number line, and make sure they go in the correct order. And we have a minus 5/8 here, and a positive 7/8 here. And where's our 0 at? Okay, we need to check 0. We always only check 0. So where's 0 at? Again, dead in the middle, right? Right in between them. Now we check it. I'm going to plug in x equals 0. So we're going to use that x equals 0. We're going to plug it in, and we're going to see if it's true or if it's false. And negative 8 times 0 is still 0. Add 1 to that, it's 1. Absolute value of 1 is 1. And is 1 now going to be smaller than 6? Is that true or is that false? Is 1 smaller than 6? True or false? In this case, it would be what? True, wouldn't it? Right? Because it's true. So, where is it true at? In the middle. That means the edges are going to be what? False and false. So they always switch back and forth. True, false, true. False, true, false. Where is it at? In the middle. What do we use? Parentheses. What does my answer look like? In interval notation, minus 5/8, comma, 7/8 with what? Parentheses. Let's do one more, and then we'll look at some special cases. So I want to do one more of these before we look at the special cases, and then we'll go back and finish 1/7. So let's do one more. And these generally are not that difficult. They take a little bit of time to go through and work out, but they're not hard. They're quite a bit easier than the others. So, what do we have here? We have an absolute value inequality. Do we need to move anything over first? Nope, it's already set up, so I'm going to put a box around it. I just do that so I don't lose track of things. Sometimes it's easier for me to put a box around it, so when I go back, I don't accidentally lose the original. So there's our original. And what is it going to look like? 7x plus 2 equals 4. Or 7x plus 2 equals a negative 4, right? Does everyone see where I got the two equations from? Okay, pretty simple on these. Now, where do students make a mistake? Students make a mistake because they forget to put it on the number line and check the answers at the end. This is, I think, one of the easiest sections, but it's also ones where students make the most mistakes because you might forget to go back and put them on a number line, or you might only give me one of the two solutions. So solve this out. So move the 2 over. So 7x equals now 2. Divide by your 7. And x now equals 2 sevenths. So there's one of them. What about the other one? Move the 2 over. 7x equals a negative 6. Divide by your 7. And x now equals a negative 6 sevenths. Put them on the number line in the correct order. Negative 6 sevenths. 2 sevenths. what are we going to check? Well, on these, we always check 0. 0 happens to be in the middle. It may not always be in the middle. It might be on one of the edges out here. But it's usually in the middle, but it can be out here as well. Now we check it. So we're going to plug 0 into 7x plus 2 is less than 4. So we plug our 0 in. So 7 times 0 is 0. So that gives you the absolute value of 2, which is 2. And in this case, is 2 going to be smaller than 4? True or false? In this case, 4 is the bigger number. It's opening towards the bigger number, right? Points towards the smaller one. So this would be true, wouldn't it? And if this came out to be true, then the edges are going to be false. And in this case, they have parentheses, right? And my answer is right here in the middle. So what does it look like now in interval notation? Well, it looks like parentheses of minus 6/7, comma, 2/7, both with parentheses. Now we need to look at what happens when the right-hand side is negative. And that is going to change things. The next ones that we're going to be looking at, we are not going to have to work out. They are either going to be true or they are going to be false. You cannot work them out and get solutions. You have to either see if they are true or false. So if the right-hand side is negative, then it is negative to positive infinity, or it is the empty set. So when we work these out and we get something where the right-hand side is negative, it is either true or it is false. And we're going to talk about some of these, and I'm going to explain why. It's either everything or it is nothing. So here's what we need to remember about absolute values. Absolute values are always positive or 0, right? Because whenever you take the absolute value of any number, no matter what it is, it's either going to come out to be a positive value or 0, right? Because what's the absolute value of a negative 8? Can someone tell me? What's the absolute value of a negative 8? Positive 8, right? Positive number. What's the absolute value of 2? Positive 2. How can it be 0? Well, what's the absolute value of 0? 0 itself, right? So absolute values are always either going to give you out positive values or 0. So let's look at this one. Notice on this one, that is negative. Now let's think about absolute values. What do we know about an absolute value? It's going to either be positive or 0. So let's assume it's positive. If absolute values are positive, can positive numbers ever equal a negative 3? Can that ever happen? No. So this is false. So it has no solution. Because absolute values are positive, and positive numbers can never be equal to a negative 3. It cannot happen. Now, inequalities can either be true or they can be false. So let's do another one of these. These are our special cases. Okay, what's special about this one? This is special because the right-hand side, again, is negative. Now, what do we know about absolute values? Positive. Okay, are positive numbers smaller than a negative 10? Are positive numbers ever smaller than a negative 10? Can that ever happen? No, right? So this one would also be what? False. And if it's false, you have no solution. Okay. Let's do another one. Now, you might think you can solve this one the way we did the others, but what is our procedure? Before we do anything else, and before we start trying to do anything with these at all, what is my first step going to be? Can someone tell me what I would do first? Yep, absolute value by itself. That's very, very important. So what are we going to do? We're going to move that 10 over. Now we look and we see what we've got. And when I move that 10 over, now it becomes a negative 6. And now we can look at it as either being true or false. Okay, so whenever the right-hand side is negative, when you start to work with these, it's either true or false. Everything or nothing. So what do we know about an absolute value? Positive or zero. So we're going to assume positive. Our positive numbers now greater than or equal to a negative 6. Is that true all the time or false? Which one? This would be what? True or false? True. Okay, so this is true. What does that tell you then your answer will be? All real numbers, negative to positive infinity. One more, and then we'll go back and finish up 1/7, because I know I forgot to do that earlier today. Let's look at this one. What do we know about this? Okay, this is 0. We're going to look at it just like it was a negative number. What do we know about absolute values? Positive or 0? Okay, so we're going to assume it's positive. It could be 0. Our positive numbers now greater than or equal to 0. Is that true or is that false? Our positive numbers bigger than 0. Yes, that would be true. Since it's true, what would your solution set be? All real numbers, so it would be negative to positive infinity. Is everyone okay with those? You just kind of see what to do. So we treat 0 kind of like a negative number. Now, if it equals 0, all you would get is one solution, right? Because you'd solve it out, you'd get that one solution. But if it's an inequality with 0, think about absolute values and think about what they give you. They give you out positive numbers, and so then it makes it either true or false. That now finishes up 1/8. And I think last time we did not quite finish 1/7. So we need to finish up the last part of 1/7. And I'd forgotten about this until we were working on the absolute values, but I wanted to finish those first. So now let's go back to 1/7 and let's talk about rational inequalities. And this is going to help us finish up 1/7. Okay, so for rational inequalities, which is 1/7, and I know we have to go backwards. I just forgot that we didn't finish it, so I'm covering it now. 1/7, the last part was rational inequalities. And when we look at rational inequalities, these are the fractions. Rational just means fractions. And we have a step-by-step procedure for these. Step number 1 is find the domain. Or actually find the numbers not in the domain. And these are always going to get parentheses. Step number 2 is you solve with an equal. So replace the inequality with an equal sign and solve. And this can have either parentheses or it can have square brackets. Once you got those, you put them on a number line. And check regions. Okay, so put them on a number line, and you check the regions. Okay, and your answer will be the true regions again. So we'll give you a minute to write these down. And these are actually pretty easy to solve. They don't take long to work with and work through. And there's only 3 of them in your homework. I'm going to do an example of each type. Okay, so let's go ahead now and try 3 of these. So we're going to start off with a very easy one. Okay, so our step-by-step procedure says we find out where it doesn't exist, where we have division by 0. That's one of them. Then we solve it, if we can, and we see if we get another one. You may or may not get another one. You may only have one. Once you have those, you put them on the number line. And then you check regions. So what are we going to have first? What number is not in the domain? Remember, we did these last time. What is not in the domain? If I look at a fraction, what number is not in the domain? Well, that's my division by 0, right? So what do we have? We have x minus 7 equals 0. So what number is not in the domain? 7. Okay, we've done those. We did those last time. That is your first step. Your second step, make it an equals and solve it if you can. Okay, so make it an equals and solve it. Well, you may or may not get another solution. In this case, we're not going to get another solution. We're only going to have one solution. Because when we try to solve this, okay, I would cross multiply, and what would we get when we try to solve it? Well, that 0 clears it out. So 2 times 1 is a 2. 0 times x minus 7 is what? 0. So this has no solution. So you only get 1. So it only has one solution. The next one that we do, that we work out, is going to have 2 of them. Okay, this one just has the 1, because that came from our domain. So what do? Place it on a number line, and we check. Step number 3, place it on a number line. We only have one number, so it's easy. All we have to check is 7, because that's the only number that we have. And I'm going to use, how about 0 and 8? Okay, I'm going to check 0 and 8, because 0 is smaller than 7, and it's easy to deal with. 8 is bigger than 7, and that's also fairly easy to deal with. Now, what are we going to check them in? We're going to use our original. So this is our original here. Okay, so this is what we're going to be using. And let's plug in our values and see if it's true or if it's false. Well, 2 divided by negative 7, that's a negative 2. And so is negative 2/7. Is that going to be bigger than 0? Is that true or is that false? Okay. Watch the way it opens. Okay, it's a negative 2/7, isn't it? Right? And you're trying to tell me that negative 2/7 is bigger than 0. Well, it's not. It's smaller, so it would actually be what? False, wouldn't it? Right? Watch the way that it opens. So that means now the left-hand side is false. What about the right-hand side? What about when we plug in 8? Okay, well, if I plug in 8, that gives you now 8 minus 7 is a 1. So that's 2 over 1. And is 2 greater than 0? True or false? This case, 2 is bigger than 0, so that would make this then what? True. Where do we shade? We shade the true region. Parentheses. There it is. Goes out to positive infinity. So what would my answer look like? 7 to positive infinity. And this is like number 8 in your homework. It's very, very similar to question number 8 in your homework. Almost identical. Different numbers, and that's it. Right? Because if you look at it, it's almost the same. Different numbers is all. Instead of it being an x minus 7, you've got an x minus 5 down below. That's the only difference. You should have time to do the next 2. So let's do 2 more. One will take a little bit of time. The other one we'll get through pretty quickly. Okay, so let's try and solve this one. So x plus 1 over x plus 3 is going to be, how about greater than 2? So it's going to be greater than 2. Now, What do we do first? Step number 1, what number is not in the domain? Can someone tell me what number is going to be down here? What number makes it 0 here? Okay, 3, right? Negative 3. Because negative 3 plus 3 makes it what? 0. Because you set that equal to 0 and solve, remember? Okay, so that's one of them. And that gets parentheses. What about the other one? This one's going to give us 2 numbers. Because we need to set it equal and solve it. So x plus 1 over x plus 3 equals 2. So I'm going to make that a 2 over 1. And unlike the last one, this one's going to be solvable. So go ahead and distribute. And that gives you x plus 1 equals 2 times x plus 3. Distribute the 2 through. Now we've got x plus 1 equals 2x, distributing through, plus 6. You move things around, so solve it however you want. Just move things around, move the 2x over, the 1 over. And now we've got minus x equals now 5, divide by negative 1. And what's my other critical point? Negative 5. So, does everyone see what we did? We set it equal. I just simply cross-multiplied. Then I distributed through, and I solved it. We can now put these on a number line. So, and this one gets parentheses. This one also gets parentheses because way back up here, it's strictly greater than. So it gets parentheses as well. So both of these are going to get parentheses. Now we're going to put our numbers on the number line. So there's your negative 5. Okay. We also have a negative 3. Make sure they go in the correct order. Here's negative 5, and here's negative 3. So we're going to check negative 6. We're going to check negative 4. And we're going to check 0, because those are our numbers. And it's the same as we've done before. It's no different. We're going to use the original, which is x plus 1 over x plus 3 is greater than 2. So that's what we're going to use to check. Okay, that's our original. We're going to plug our values in, and we're going to see what the signs come out to be, whether it's true or false. And so I'm going to start with a negative 6. So plug in that negative 6 there. That's our first value. And negative 6 plus 1, that's a negative 5. And minus 6 plus 3, okay, that comes out to be a negative 3. Negative and negative makes it a positive 5/3. And is that bigger than 2? Well, if you can't see, check it with a calculator. 5 over 3. Okay, 5 over 3 with the calculator is 1 if we round 7. And is 1.7, is that bigger than 2? Is that true or false now? False. Okay, so that first region is false. So this region here is false. Now we check the next region. And in the next region we had negative 4. So the next region, we're going to plug in negative 4. Minus 4 plus 1, that's a minus 3. Minus 4 plus 1 That's a minus 1. Negative and negative makes it a positive 3. And is 3 bigger than 2? True or false now? Is 3 bigger than 2? Yes, it is. So that's going to be true. We've got one more region to check. And we're going to check 0. It's going to actually be the easiest. So we're going to check 0. 0 plus 1 over 0 plus 3. That gives you a third. And is a third bigger than 2? True or false? Is 1/3 bigger than 2? No, it is not. So that again would be false. Okay, so we've got it. Right? How do our regions go? False, true, false. Where do we shade? In the middle. What's our answer? -5 to what? -3. Just in the sake of time, instead of working out an example like 10, I'm going to work 10 for you from your homework. And by the way, this one is going to be like, just so we can see it here, this one is going to be like number 9 in the homework. So this one's going to be like number 9 in the homework that we just did. I am going to work out 10. And this one will not take long to work out. I am going to work out question number 10 for you. And before I forget, let me go ahead and pass out the sign-in sheet while we work out this question. So let me find the sign-in sheet here, and I'll pass that around. Okay, so let's finish this one out. Now, this is the only one like it, and I want us to use some thinking here. Okay? Specifically here, let's think about an absolute value and a square. And they're very similar. When you take an absolute value of a number, what does it come out to be? Absolute value is either positive or what? 0. Okay? Squares work the same, because when you square a negative, what does it become? Positive. So what do we know here? We know that this part must be positive, right? Okay? So, what does this make our answer then? True or false? If we look at it as a positive number, 8 divided by a positive number, it stays positive, right? So 8 divided by a positive number is positive. And our positive numbers, are they going to be less than 0? No. So this one would be false, right? And you would have what? No solution. So we just didn't quite have enough time to cover an example of one of these, so I just worked it out. So for question 10 in your homework, right, what's the answer going to be? The answer is going to be no solution. Because that cannot happen, because when you square